All right, let's go look at these fractions. I'm going to have to erase some of this because it's a little busy on the page. So I'm just going to erase B and D. If you need to hit pause to catch all that or rewind it, go ahead and do that now. All right, so we've done D here, but let's go back and look at our fractions. Each one of these is slightly different. The square root of 24 over the square root of 16. The square root of 16 is a perfect square, so I'm just going to go ahead and say this is the square root of 24 over 4. I did it that way because 16 is a perfect square. Goes ahead and gets rid of that. I don't like square roots in my denominator. That's the rule that we had back on the other page when we were going over the square root rules. I do need to go the second step and reduce the square root of 24. So I'm going to make a factor tree for 24 over here. Does it matter how you want to start this? I'll do 2 times 12. We're going to pull out our 2's. We're going to throw back in what doesn't have a pair. And I'm going to leave that denominator as well. So 2. Underneath the square root, I'll get 6 because I'm multiplying. And then the denominator, I have 4. Wouldn't it be nice if that was our final answer? It's not our final answer. Don't just go type this in your calculator because it's going to be nasty. But I can reduce down the rational number. So kind of ignore the irrational right now. It's not really a like term. We're not combining it. But 2/4, you can type that in your calculator if you want to. That reduces down just to 1/2. So that could be 1 square root of 6 over 2. That 1/2. Or just square root of 6 over 2. I would be happy with either one of those. You could, it's not exactly the same, but you could kind of think about that square root being an x. If I had in algebra 2x over 4, I would want to reduce that down to 1/2 x or x over 2. So very similar to that, we would want to reduce that down with the square root. I think C is the trickiest one. All right, E. E, I'm going to use that quotient rule. I'm going to break this up into the square root of 8 over the square root of 9. The reason I want to do that on this one is the square root of 9 is a perfect square. That's 3. And then just like before, I'm going to reduce 8 down. I'm going to pull out a 2. I've got another 2 left over. And this one's a lot easier because 2 over 3 doesn't reduce down. 2/3 is as most reduced as we can get. You can check that in your calculator by having it reduce down the fraction if you just don't type in the square root, but you can type in 2/3, do the buttons on your calculator to make it reduce. I'll be happy to show you how to do that on your calculator if you bring it to class. You reduce that down and you see that it's 2/3 is as reduced as it can get. Now a lot of people get confused with E and F here. The difference is the denominator of E was that perfect square. It was 9. The denominator F is 3. That is not a perfect square. The square root of 3 is something like nasty. So I'm going to treat it differently. I am not going to break it up. Instead, 75 over 3 is 25. Just type it in, 75 divided by 3. And I kind of knew that was my next thing to try since I can't reduce the square root of 3. And if you didn't see that, that's okay. That's why we're going over it. So now you know that is an option. So the square root of 25 is just 5. We can type that in our calculator. It gives us a perfect answer. Be on the lookout. A lot of times on the class assignments and the test, we will give you one that is a perfect answer there. And sometimes people are like, whoa, like something's wrong. It's not wrong. They do work out. They can give you that perfect answer.